To start out with practicing a number talk that we usually use for upper grade, and I want you to try to solve it without using paper and without using an algorithm. And when you have solved 18 times 5, I want you to put your thumb by your heart. Okay, and the way that I would do it in my classroom is I would tell all the kids, I would wait until you see all the kids with their thumbs by their heart, or at least close to most of them having it. And then if you actually have another answer, so if you're done with the first one, you don't just stop there. You keep thinking about another way to solve the problem. Then I would have them do a peace sign. Then I would have them do 3, 4, as many times as they can think of, so that they're not just doing one way of solving it. That helps the students that are more advanced learners to keep thinking about the problem. Okay, so on the count of, and then I would ask them on the count of 3, please whisper your answer. So 1, 2, 3. Now, then I ask the students, okay, so who would like to share their strategy? Okay, who would like to share their strategy?
Okay.
Okay, yes.
Okay, so I broke it up, I chunked it. So I multiplied 5 times 10, which would give me 50, and then 5 times 8, which would give me 40, and then I added it. 50 plus 40 would give me 90.
If that's the aha moment there. If you did it that way, can you show us by going same as? If you did it the same way as April did it? Okay.
Okay, great job, April. I see that you use place value and the distributive property. And see, this way the students are seeing the vocabulary within the context of the lesson. Well, actually, it's not a lesson, it's a distributive. Is there anyone who would like to share their strategy? And then you also have to change colors so you give them credit for their work. Donna?
Well, I thought it looked really hard, so I thought, how could I make that easy? And I thought, wow, 18's almost 20.
Okay.
And I said, 18's 2 less than 20. So then I just went with my little head. Make sure I was right. 20, 40, 60, 81. I thought, yes.
Okay. 20, 40,
60, 81. And then I knew that there
81.
100. Oh, 100.
Oh,
I'm
thank
sorry.
you. No, I just want to make sure that I'm writing it exactly the way you're thinking.
No,
That's what I have to make sure that I get with the students.
And then I
Okay.
knew that there were 5 groups of, so I went 5 times 2 would give me the 10 because each one was less than 20 by 2. So I went 5 times 2 equal 10. And then I went 100 minus 10. And I got 90. And it made sense in my head.
Okay. So Donna added 2, added, and then also use subtraction, right?
Yes.
And multiplication here, right? So see how they're seeing the vocabulary? Can I get one more volunteer?
I was visualizing 2 different arrays.
Okay, can do that too. Tell me how.
I actually did like 5 times 10.
Okay, so I hope I'm visualizing it or drawing it the way that you visualized it. And then I can go, that's a 6, right? And they said visuals are very powerful for students. So this is an excellent example of that. So then this is.
And then I did 5 times 8.
Okay. Shanice, I'm sorry, but can you help me spell your name? Sorry, I had to see it. Okay. Shanisa used arrays to solve the problem and addition.
this shows our students is that numbers are flexible. Okay, numbers are flexible, and it's not just about fluency. It's not just about knowing math facts, but what they actually really mean. Okay, to be fluent means that students feel comfortable in breaking numbers apart and actually putting numbers together. They understand that numbers have a relationship.
And what this is building upon is for when our students get into the middle school and high school for algebra. Think about FOIL and the distributive property, how important that is. And so that's what they're finding is when they get into the upper grades, they don't have that flexibility with numbers. And so this is going to be very beneficial. Yes.
I have a question. So, do you think that it would be good to have like do poster math with them, and you could pose that problem and have them start doing their problems, and you watch them, and then have them put them up different ways so like students can all see, oh, you can do it this way, you can do it that way, so it looks like
Maybe
like that.
sticky notes.
That would,
You want to go to Bill? I was going to say, I think this is kind of like helping them to build some of those strategies that they might use during poster math. But there's, well, you could, although you could use the same problem for poster math. I would say that this is different. This is separate. This is the number talk. This is a time when the kids are you're talking about it. Yeah, you see all the strategies that they could use. Maybe a student that doesn't have a strategy would come and learn new strategies that they could apply when they are doing the lesson, the poster math, or any other interactive lesson.
Yes.
As Nancy said earlier, it's very short. It's only about 10 to 15 minutes. This takes in the time.
and if you notice, the teacher didn't talk as much. It was the students producing the work and the thinking. Right?
Sorry, guys. Oh, there. All right, so as part of our paper, we had to include our core philosophies. And as researchers, we believe in continuing to improve teaching practices and provide the most effective strategies to promote student learning. And we believe in teaching conceptually rather than directly.
We believe our role is to facilitate instead of being the primary source of instruction. We believe direct instruction is valuable and should remain a part of our instructional practices to introduce big ideas and guide small group instruction.
We believe in a growth mindset, which has allowed us to change our perspective of what math is. And we believe that math concepts are not isolated but interconnected.
So that is what we came upon with our philosophy as we learned number talks.
So, within our paper, we also had to include what was the problem that we were seeing within our classrooms and with our students, as well as the purpose of our study, and then we had to formulate questions. So the problems that we were noticing is that students are failing to reason mathematically. They were also not making sense of numerical relationships. Our students were not being able to understand and construct and use strategies effectively, so viable strategies. Not able to persevere, giving up too easily. They're getting tired. Oh, this is hard. And not motivated or interested in mathematics. So what we decided, and the purpose is to find out if number talks aid in helping fourth graders develop number sense, and if it helps them to persevere through problems, which led then to our questions and what led to our research. So our first question was, in what ways will the use of number talks improve students' fourth grade math proficiency? And second, in what ways will using number talks increase student motivation? And then as part of our paper, we had to include the academic language.
Okay, so what is a literature review, which was part of our capstone? Current knowledge, including substantive findings, theoretical and methodological contributions to a particular topic, use secondary sources, and do not report new or original experimental work.
So going into our next slides, as part of our literature review, we didn't want to have pages and pages up here for you to read, so we pulled out some really great quotes that we had, that we read as we were going through our research. So we'll share some of those. So number sense involves an intuition about numbers and an interconnectedness intelligence, which includes the ability to make reasonable estimations, compose and decompose whole numbers, understand and correctly apply basic mathematical operations when problem solving, and use the commutative, associative, and distributive properties. This was powerful. So it says, for decades, the National Assessment of Educational Progress has shown elementary school children are weak in number sense. So Tracy Muir argued that students who fail to acquire the pieces that make up number sense as early as kindergarten are at greatest risk for failure in mathematics in the long term. So consequently, many students enter middle school lacking the foundation from which to build algebraic understanding and are at a considerable disadvantage when studying algebra in high school. And I mentioned on that when we were working on solving these problems here. And a recent study of 187th graders conducted by the University of Missouri revealed many students who lagged behind peers in basic math skills were the same students who had the least number sense or fluency as far back as first grade.
Number talks include 5 fundamental elements that guide educators to promote mental math and computational skills. Parrish defined the necessary parts as classroom environment, having a safe environment, classroom discussion, teacher's role of mental math, and purposeful computation problems. So what that means is just not any math problems, they have to build upon each other. Oh, did we miss one?
Yeah, I think so.
Oh, can you go back to this one? I think it's gonna pop up. Can you go back this way? Yeah. There we go. Number talks are not to replace the core curriculum. Rather, number talks should support and promote numerical accuracy, efficiency, flexibility, and mathematical generalizations that can be applied to all realms of mathematics.
And while doing the literature review, I worked on the motivational piece. And so according to Larson, traditional classrooms squash curiosity and diminish creativity. Students come to school with sufficient motivation in kindergarten. However, by 3rd grade, the traditional environment succeeds in lowering enthusiasm towards learning. Therefore, an academic focus is not enough to help learners do well in school. Also, the best environment conducive to increased performance in math and propelled by motivation is an inquiry-based, supportive, student-centered classroom. Just as students are given the opportunity to learn, they should be given the tools to be successful in the classroom environment when it comes to motivation. Motivation comes from within, and it is sustained by beliefs in one's personal abilities. Now, when we started, we used my classroom as the intervention classroom. So all of the statistics that you see here, this is what my classroom looks like, and I'm sure it reflects the school as a whole. Also, there's 52% English language learners, 16% that are in special education, 96% that are socioeconomically disadvantaged. I have half and half. Pretty much my class is pretty balanced. 52% boys, 48% girls, 92% Hispanic, 4% African American, and 4% white. In the role of the researchers, Mrs. Chrisman and Mrs. Gowanau were researchers 1 and 2. They're the data analysts, and as I had stated earlier, I'm the intervention teacher. The need for intervention came about when we looked at our SBAC scores from the previous year, which I know are preliminary scores because we hadn't really done the test. So we would take that into consideration, but that's the data that we used for our presentation and for our paper. A third of the students were ready for 4th grade math, and 2/3 need an effective intervention. So that's one of the reasons why we chose number talks. And so again, I will just review what it takes to do a number talk lesson, and later on we'll be passing out a sheet that gives you detailed information about it in case you want to do it in your classroom. We're hoping. Number 1, teacher presents a problem, and it could be a basic problem, or it could even be a word problem. The students figure out the answer, and they put their thumb by their heart. The students share their answer, and you could do it several different ways. Usually you try to get at least 3 people, and in this manner. The class agrees on an answer, because sometimes they have different answers, and and I like that they have to justify their answers. The steps are repeated again. If you have, sometimes you have a sequence of numbers. If you get into the Number Talks book by Sherry Parrish that we use for our research, gives you a series where you're like building and you're showing them that sequencing to get them to where they need to be for like bigger problems. When we started, we started out with in week 1 with a pretest, and I used the Share Out Strategy Problem Series. And every week they had to take a survey on their feelings towards math. Week 2, we use a partial quotient strategy problem series and another survey at the end of the week. Week 3, we use a multiplying up strategy problem series and a survey. Week 4, I gave them the post test and a survey. And week 5, we had our February break, so we had a little break in there. And then week 6, I conducted student interviews.
So, of all that Janet's hard work there. So what were the data collection methods that we used? We'll use multiple data sources were used to collect data and triangulate it in order to make sure that our conclusions were favorable. So we used 6-question pre and post math assessment. We had student interviews. There were 3 students that were interviewed. We had open-ended survey questions about their attitudes towards math, and observations and reflection journals. I think I took yours.
That's okay.
didn't
That's
I?
okay. I was like, that's okay. Okay, and to ensure the validity of the data collected during our action research project, we implemented a number of strategies. So there's 3 strategies that we had to use: truth value validity, transferability, and outcome validity.
Alright. And then confidentiality, because we had to make sure that our students' privacy was kept. Confidentiality of the students' participation in our action research study was of the utmost